Hello, everybody. Today, this week, we're going to reorganize formulas. It's a very important skill in science, and if you're doing some math, you're probably going into that this week or next week in math. Uh, how to move numbers around, how to move letters around in order to get the proper focus on our equation. Let's dive right into it. I don't want to waste any time. Put you a small video here. You're lucky I found one. Can't find any for French, so it looks like there's a market there that I'd like to approach. Now let's see. If you have a formula like this, so we're going to take 20 minutes to just understand why we're doing it. Why we're doing it. This is a real formula. The force necessary to move a mass and accelerate it can be found using this formula. So if we want to move a mass of 1 kilogram, actually moving it is not what A means. A means accelerate. So if you want to accelerate a mass of 1 kilogram, so you want to accelerate it by 2 meters per second squared. So you're accelerating it. What is going to be the necessary force to do that? And by force, I mean there's a string here, and someone is pulling the string, which is where the force necessary comes from. So the force is unknown. But if we want to accelerate a mass of 1 kilogram at a rate of 2 meters per second square, we can ask using the formula. So basically, this is a formula to help you find F, right? Because you don't have to do any math. You just have to replace. M is 1, A is 2, and you basically get the answer. 1 times 2 is 2. If you would have wrote the units, kilograms per meter over second square, this would have been kept here, kilogram meter per second square, or more commonly known as newtons. A newton is how much force is necessary to push something. Or how much force necessary to accelerate something. So that formula is clearly a formula to help you find the force if you have the acceleration and the mass. But what if we have a different situation? And by the way, this is all true. This all works out. 2 Newton is a real thing. You can measure that. 2 meters per second is a real thing. 1 kilogram is real, and it all works out. If you were to pull a 1 kilogram mass and accelerate at that rate, what you pull with would read 2 Newton, and there's reasons for that. Okay, now let's say instead that you have the same guy or girl who's accelerating at, again, a force of 2 Newton. But this time they're accelerating a mass of 4 kilograms. Not 1, but 4. And we can ask ourselves, well, what's going to be the acceleration this time? Because think about it, the person is pulling with the same strength, but the object is more massive. So we have to also think that it's on ice. It's not on the ground, it's on ice, okay? Friction will come in Physics 11. We'll talk about friction. But for now, imagine in space, imagine on ice. 2 Newton, you were able to pull a little mass, and then 2 Newton, and you're going to pull a bigger mass, right? Which one is going to be faster? Which one is going to go faster? The small mass, right? Because you're pulling it with the same force, and it's less massive, so it's going to fly a lot faster. But we don't need to do the math in our head. We have to do it on paper. So let's see now. Let's take our formula again. F equals ma. This time I have F. I also have M, and I don't have A. Okay, so you can do physics like this. You can do math like this. As a matter of fact, you're probably doing math like that right now. But if you'd been in my class, I told you to stick around to the science class because we're going to do something. It's going to save you some time. So what are you allowed to do? So if you're doing math right now, you've seen bedmiss in reverse, bedmiss in reverse. Pay attention. So you want to isolate A. That's our target. But what's happening to A? So a quick review in case someone was not paying attention in math. What's happening to A right now? It's being multiplied by 4. We don't want that. We just want A. What's the opposite of multiplying by 4? Dividing by 4. So we will be doing this. We will divide by 4 on both sides. Because if you do it on one side, you have to do it on the other. It's got to be fair. So we'll do that. And again, more details. You don't have to think about, oh, what are you dividing here? This, or maybe this and that, and none of that. You're dividing one side and the other side. You're always doing that. So I'm not thinking right now, I'm just doing. So let's do. 2 divided by 4, 4a divided by 4. What happens here? So 4 times a divided by 4. So I have a times that a by 4. And then I divide it by 4 again. So I go right back to where I was. Or if I write this, so I can write this like such, or I could have wrote like such. 4 divided by 4 cancels out. It becomes 1, 1a, or simply a. So pay attention in math. It's going to matter in science from now on, if not already. So 2 divided by 4, nice. That's 0.5 equals a. Bingo. So what happened? Well, we had to do something to the equation to find our answer. You'll also notice that I did not use my head and say, well, all right, if this is 2 and this is 4, and this has to be a half. None of that. That's over. Game over. None of that. That's finished. You can put your numbers in, and then you got to do things to it. That's the new game. So that gave us our answer. Okay, but the issue arises when you think you want to do that every time you do physics, which is not the case. Because you're actually writing a lot more than you should. And this week, we're going to be reorganizing formulas sometimes without numbers, sometimes with numbers. Some formulas have numbers, other formulas don't have numbers. So let's say now that, okay, I'd like to find A. I'm going to isolate A. Isolate A. So we're gonna do the same thing we just did, but this time using letters. And you'll notice that it doesn't really matter what the situation is, 1 kilogram, 4 kilogram, who cares? This is just about making a formula. So isolate A. So what's being done to A right now? It's being multiplied by M. We don't want that. What's the opposite of multiplying by M? Dividing by M, which we will do on both sides. So F is going to be divided by M, and MA is going to be divided by M. M and M here are going to cancel out because there's one on top and one on the bottom, and they can be grouped together. And M over M is 1, right? The same way that 4 over 4 is 1, or minus 2 over minus 2. It's the same letter. You get my point. F over M equals A. And that's a different formula. Even though it's the same, it comes from the same formula, it means something else. You see here, what this formula means here is that if you increase M, you will increase F, right? If the mass is not 1 kilogram, but 2 kilograms, you'll need 2 times more F. You can try it. Just put 1 instead of A. If it's 1, it would be 1. If it's 2, it would be 2. Also says that if you accelerate, if you increase your acceleration, so say you have a 1 kilogram and you accelerate it at 2 meters per second or at 4 meters per second, so 2 times, then it will also increase the force necessary by 2 times. So the way that this formula is set up makes it very simple to figure out what physics is. If you increase the mass, you'll need more force. If you increase the acceleration at which you want it to go, you will need more force. But this formula over here is saying a different story. This formula is saying if you increase the force, let me remove some of that stuff, just watch the video. If you increase the force here by 2 times, what happens to A? So say you had 1 divided by 1, then A would be 1. But if this becomes 2, then this becomes 2. So 2 times also. Okay, so if you increase what's on top of side, right? If you increase what's on top here, you also increase that that number, like we just did. If you increase this, what happens? So say you had 1, divide by 1, that would be 1. So the acceleration of for 1 Newton over 1 kilogram mass would be 1 meter per second square. But if this becomes 2, by increasing the mass from 1 kilogram to 2 kilogram and not changing the F, that means that this is not 1 anymore, it's a half, 0.5. So instead of 1, it becomes a half. So what this means is the person that pulls, so if I have a person pulls a 1 kilogram block with a force of 1 Newton, the person will go at 1 meter per second square. But if I put another block on top of it, like this, Now it's 2 kilograms. If the person still pulls at 1 Newton, he will go half that speed. That's what this means. So knowing these numbers by heart is not what matters. What matters is the understanding that if you increase what's on the bottom of a fraction, it reduces. So you've increased the mass, it reduces the answer. Let me show you again. No. Calm down, listen to me. If you increase F, you increase A. If you increase M, you reduce A. This is not a fact of science. It's a fact of mathematics. Okay? And this formula works in nature all the time, everywhere, forever, hopefully. So what's my point? My point is that this formula is a formula for acceleration. This formula is a formula for force. The focus or the subject here is the force. The subject here is the acceleration. And when we do our science, we never take the initial formula. We take the one that will give us the answer. Because we're not doing math, we're doing science. So we want to take that knowledge that we have and drop it. Okay. And drop it. Let's see. Oh, examples, yes. Yours in English, it's the same one. Let's do a few examples. My voice is cutting out. So we're going to try and do some more examples. Okay, dv equals d over t. So if I say isolate 4d, or simply isolate d, then what do you need to do? So d is currently being divided by t. That's a problem. We don't want to divide by t, right? That's sad. We don't want to divide d by t. In fact, if d was not divided by t, we would be happy because that job would have been done. What's the opposite of dividing by t? Multiplying by t. This means multiply. We're going to do times t, and you're going to see why I don't like x here. So if you divide by t and multiply by t, it should cancel out. So let's do that. We're going to multiply by t. So that means that both sides of the equal are simply multiplied by t. Vt, v times t equals d over t times t. So you can clearly see why I don't like the x's, because the x's here don't mean x, they mean time. So we're not going to use them. We're not going to do that. When we do algebra, we're not going to do that. Instead, we're going to show that there is a multiplication, but we're going to use brackets instead. And once you get really good, you don't need brackets, because Vt means V times t. But for now, we'll keep them. So what happens on this side? We have Vt. We could remove the brackets here. Equals, and then what happens here? So d times t divide by t. So d times t divide by t. Okay, that's what I said. That's 1. So d times 1 is 1, or d times 1 is d. So d would just cancel out. those two. There's one on top, one on the bottom. So we've isolated D. Now that's a formula for distance. So if you're going at 60 kilometers per hour for, I don't know, 4 hours, then your distance will be 60 times 4, 240, hour, divide by hour, times hour. Can you see that here? There's a times hour and the divide by hour, so they cancel out. You only stay with kilometers. D. Basically, if I want the distance, I would use that formula. Could use this one, but there's work to do. So we'll use this one. Let's isolate for T. Isolate T. So here, if I want to isolate T, what would I do? All right, T's here. That's our target right there. T's there. T is being multiplied by V. We don't want that. Let's divide both sides by V because it's times V. The opposite is divide by V. So VT divided by V, again, the whole side is equal to D divided by V. What happens here? V times V divided by V goes away. T equals D over V. That was fast because you're getting better. Now, we could have made a mistake. Can you tell me where? Here. What tells you that this is right? Yet you answered both questions using, like you answered the second question. We've answered the second question using the first answer of the first question, the answer of the first question. We should not be doing this. You never know when you're going to make a mistake. So you, instead of taking this, we should have taken the first statement. So we're going to take the first statement, and we're going to do something very special that you may have never done before. I don't know. V is D over T. Isolate T. Okay. So the easy part here was that we were asking ourselves for D, what is being done to D? And we figured it out, what's being done to D. But here, can we ask what's being done to T? What is being done to time? No, it's not the right question. So that's why we're going to choose a different way of going about this problem. Normally, when you want the letter, you never do anything with the letter. You do things with other letters or other numbers every time. Like you leave it alone and you always take what's around it, like a plus or a times, and you kind of deal with that. You never really mention that letter in your operations. You'll see, like every time we'll never use the same letter. We always work with other letters and other numbers. We're going to use it. We're going to use the same letter that we're trying to isolate. And it's a classical example. Just get to it. We could say we're going to say that having T under here is bad because we don't want the answer to be 1 over T. Like we don't want T here. We want T on top. So how do you bring T on top? Because it's under. Big problem. How do you bring it on top? What can you do? You have to do something. And it's always the same thing. You times by t, or you times by the bottom. Let's see what that does when you do it. So v times t is equal to d over t times t. They cancel out, and you end up like this. Now he's on top. Oof, top. Okay. So what did we do? We just timed by t. That got it from under back on top. When we timed by t, we got rid of the bottom, divide by t. And collateral damage, we got a t on top here. And that's good, because now we have a hope to isolate t and have an answer that looks like t equals something and not 1 over t equals something. So what do we have to do here? Well, the same thing that we did earlier. So you want just t, you're going to divide by v, cancel out, t equals d over v. Let's do a few examples. So now this is an equation for time. Think about that. Like, every paper is going to use that equation. Not necessarily this, because they'll have to make a mess on their paper. Okay. So we're going to use this. So that means if you know the distance to be 100 meters, and you know the velocity, you're going at, I don't know, 15 meters per second, which is pretty fast. You'll be there in 6.5 seconds. Or something like that. 7.5. 6, 7. A equals x plus 6. We have to identify for x. All the examples will ask you to isolate x, or make x the subject, which means isolate. So what do you have to do on both sides? Or should I say, what do you have to do on this side to isolate x? Right, so there's a plus 6 being added that we don't want. We wish it was simply this. No anything. No plus 6, no nothing. So how do we get from here to here? What do we have to do? You're going to do what? Minus 6. Right, so the opposite of plus 6 will be minus 6. What you do on one side, you do on the other. So a minus 6 is equal to x plus 6 minus 6. So what I did on one side, I'm doing on both sides, here and here. This is technically what's happening. Some of you would simply choose to write like minus 6, something like that. Yeah, I'm cool with that too. Plus 6 minus 6, done. A minus 6 is equal to x. That's an isolation for x. X is now the subject, which means that, you know, if we add x here, like, so you add xa, 0, 1, 2, 3, you have x. You can find a so easily, can't you? Like 0 plus 6 is 6, 1 plus 6, 7, 8, 9. Easy, right? But instead, imagine that I have A, 0, 1, 2, 3. Now what? How do you get X? 0 is A, X is what? Can you see what's going on in the head right now? We're trying to figure out what this mystery box is. What a waste of time. What a waste of energy. Let's not do that. Instead, let's do the operation, end up with this equation, and from this equation it becomes really easy. 0 minus 6 is X, so minus 6. 1 minus 6, minus 5. 2 here, minus 4. A 3 here, minus 3, right? So you can see the value in having this formula up and ready when you want to work on a project, okay? Let's continue. And that's why it's in physics. Yeah. 7x is C. 7x is C. We have to find x. So what do we do? 7 times x right now. We don't do that. We don't want that. So we'll divide both sides by 7, canceling them. X is 7 over C. C over 7, sorry. So you can go really fast when you grasp. But there's only one step here also. There was only one step here. Let's do another one. Hx is equal to 5m. Okay, so again, one step. You want to find x. That's our target. What's being done to x right now? Multiplied by h. We don't want that. The opposite of multiply by h is divide by h. So hx over h is equal to 5m over h. H cancels out. You get x equals 5m over h. Some of you may notice that the h here that timed x is now dividing 5m. It's like the opposite. It's like it went from here to here, but in the right way. You'd be right. Sometimes when we teach math, we talk like that. We'll say we'll bring h under here. But that's what it means. This is the final answer, proper answer. Let's take one that's a little more complex here. 5x minus 7 over 3. So our target is here. That's x. What do we have to do? So we're going to need a tool, BEDMAS in reverse. So BEDMAS in reverse when you isolate. Okay. And we have to be careful. We have to know what we're doing with BEDMAS. Any adding, subtracting? Yes, actually there is right here. But there's an issue. This can be rewritten as this. Except there's a problem here. This is not true. If I put brackets, it becomes true. Right, so this actually means this. So there's a kind of a invisible bracket here. And so before we can get into that bracket, we have to clean it around. We have to clean around it. And so as you can see, before we get in, we have to take care of the divide by 3. That's the first thing. And it's kind of natural. right? We can just get rid of this whole division here. We're saying that y is a third of this top part. So let's put some order into that. So what do we have to do to clean around it here? We have to multiply by 3. What is that going to do? And you'll see why this is the best thing you can do. So y times 3 is 3y. And on this side, 5x minus 7 divided by 3 times 3. And we have to be careful. I put it next to this line, but I can do this too. Okay, so this times 3 divided by 3 cancels out. You get this nice line here, 5x minus 7. The brackets now can be taken off. So we're getting closer. Now we can start doing the Bedmes in reverse, as you can see. We're actually doing it, it's just hard for me to explain. So adding, subtracting, yes, there is one. Let's do it. What's the opposite of minus 7? Plus 7. So we're doing plus 7 on both sides. So 3y plus 7 is equal to, you can simply write the answer if you know it. It's just 5x. We did plus 7 in our heads. Like you can do plus 7, cancel that out. Do you feel my flow? 3y plus 7 is 5x. Nice. We don't want 5 in front of x. 5 is timing x. So what's the opposite of times 5? Divide by 5. So what do we divide by 5 again? The whole thing, indeed. By 5, the whole thing by 5. We can cancel out things that are evident to cancel. And if you can see it, we're going to start with this here. We're going to say x, which is alone on this side, is going to be equal to this whole thing, which is fairly beautiful and fairly simple. Ta-da! That's the answer for your problem over there. Okay, so I want you to notice that we did 3 things here. So it's a little more complicated, and that's why it's one of the last ones. So we did 3 things. We only did 3 things. I just took an hour to explain it. So 3 here. For this one, it was 1 operation. For this one, it was 1 operation. Here 2 operations and 1 operations. So pretty fast. Okay, I hope that you guys can do all that. Take your time. One I'd like to show you also. I'll do one more. We'll do a square. Let's do the square here. Target acquired, the x. We want the x. Okay. Any adding or subtracting on this side? No. Done. Any multiplying or dividing? Yes. The 2 here is timing, the variable that we care about. What's the, we're going to divide by 2, right? Because it's being timed by 2. So 2x squared divided by 2 is equal to 40r divided by 2. 2's cancel out. You're left with x squared. Here, there's things canceling out. If I do a good math job, 40 and 2 can be simplified into 20 and 1. And so that's also what's happening. 20r divided by 1. You don't need to write that. Right? 20r divided by 1. You don't need to write divide by 1. Almost there. Is x multiplied by anything? No. Is there an exponent? Yeah, a square. Okay, what's the opposite of a square? Yeah. What's the opposite of a square? 3 squared is 9. So what do you have to do to 9 to get back to 3? Square root. So square and square roots are the opposites of each other. So can we square root both sides? Yeah. Yeah, you can. In fact, you can do whatever you want. It's just an example of how cool math can be. So divide the square root both sides. Literally like square root both sides. Straight up like this. I'm just writing more than I need to. Okay, so what happens to x? It becomes x. X squared becomes x. You've rooted the square. Like it's like rooting 3 squared. The answer is 3. You can pause here to think. What happens to the other side? So let me just cross that and that. I don't like that. What happens on the other side? Well, it's going to stay like this until you reach 10th grade, and you're going to figure it out. But honestly, that's a nice answer. I like it. It's a fine answer. Okay, so basically, Bedmish in reverse, that thing works. Yeah. I hope that helped you, and you can finish some of that homework over here. Don't forget to take a break. Take care, guys. I'll be around.